Hello everyone, welcome to another session of Schneider Electric PLC training tutorials where we will learn Schneider Electric PLC programming. Let's see what we have to cover in this presentation. In this presentation, we are going to be handling PLC analog input-output, also known as analog IOs. So to begin, we will start by understanding what a PLC analog IO is, the application of PLC analog IOs, the configuration of PLC analog IOs, how they can be configured, and the programming of analog IOs. Please, if you have not yet subscribed to this channel, please do well to click on the subscribe button and hit the notification bell so that you don't miss any of our upcoming videos. Now to begin, we will start by understanding digital sensors and actuators. So digital sensors sense information to the PLC, and the PLC performs some calculation and sends information back to the real world through digital actuators. And digital sensors and actuators can process logic that is either a 0 or a 1, a true or a false. Like for example, a push button. Push button can either assume the logic 1 state or the logic 0 state. And these LEDs can either accept a logic 1 state, which is the on state, or a logic 0 state, which is the off state. Now coming to analog sensors and actuators, on the other hand, they can also send information from the real world to the PLC, and the PLC performs some calculations and give it out to the real world through analog actuators. Basically, unlike digital sensors and actuators, analog sensors and actuators can process values in continuous domain of time. That is, they can have infinite range of values, unlike digital sensors that have just discrete state of values 0 or 1. A typical signal ranges of analog IOs include 0 to 10 volts, minus 10 to 10 volts, 0 to 20 milliamps, and 4 to 20 milliamps. It is important to note that a total of 16 bits of input-output memory is usually made available for analog IO signal processing. Now, what are some of the applications of analog IOs? Analog IOs can be used, for example, we have this reservoir where we are constantly monitoring the pressure through this pressure transmitter. Now, this pressure transmitter can give out an analog signal of the range of 4 to 20 milliamps. On the other hand, the PLC now interprets this information or receives this information in the range of 0 to 10,000. So this is a typical range of some of the analog IO module for our PLC. Now, if this pressure transmitter can sense pressure up to 100 kilopascal, from 0 to 100 kilopascal, then it means that our PLC should be able to convert this 4 to 20 milliamps to 0 to 100,000 pascal. Okay. So this is what we are going to see in our PLC application. The module is responsible for, the IO module is responsible for giving these values to the PLC 0 to 10,000. And our PLC manipulation now should be able to range these 4 to 20 milliamps to 0 to 100,000 pascal. Now let's jump into our application and see how we can convert a 4 to 20 milliamps to a 0 to 100,000 pascal. I already have a project open. What I will do is I will start a new project, a new session, and I will call that session should be in ladder, and I will call that session analog scaling. So this is our main function, but we are now going to create a derived function block that is going to process our signal. We will create a derived function block. Before we do that derived function block, we will go to IO configuration. And under our IO configuration, we are going to set our module. So this is a module that we want to work with. We want to work with this AMM0600. Now, if you click on this module, double click on that module, you see that that module has 6 channels. It has 4 input channels and 2 output channels. We'll be working with the input channel. And in this input channel, you can see the type of signals that it can process. So you can process plus or minus 10 volts, you can process 0 to 10 volts, you can process 0 to 20 milliamps, and you can process 4 to 20 milliamps. Okay, so we will be working with 4 to 20 milliamps. And this is the range. Okay, 4 to 20 milliamps corresponds to 0 to 10,000. These are overshoot values, okay? Be the outside range, all right? An acceptable outside range. We can also use it to determine if the sensor is giving the real value or not, but we're just going to allow it like that. So let's take note of this value 0 to 10,000. And the filter, we'll just allow the filter 0, so it's about the sensitivity of the measurement, okay, the speed of the measurement. All right. So next, we are now going to go back to our main block. It's our main block, and now we are going to open our variables and function block instances. We are going to go to derive function blocks. We will not create a block. We want to create a function that is going to perform that calculation for us, and we are going to call that function analog read, or we'll just call it read analog. So I'm going to call it read analog. Okay, so we'll say db or dfb, which stands for derive function blocks. Then I'll hit OK. Now there are some parameters that we have to set. First, we have to set the input parameters. So we need 4 input parameters that we have to define, and 1 which is going to be the true value. So first, we will set the limit of the incoming signal, and we are going to call the upper limit from max and the lower limit from min. Then we will call the incoming signal value, that is our input signal. Okay, all of this has to be in int because our sensor sends values in integer format. So there will be int. The incoming signal will also be in int. Now we have to specify the range that we want to convert it to. So we will say to max. This one now will have to be a real value, and we will say to min, which is also a real value. And for our output, we'll now go to our output. For our output, we want an error signal, and this error signal will tell us whether the incoming value is within the specified limit. Otherwise, we want to activate that error. So that error will be a Boolean error. It's going to be a Boolean variable, and we have our output, and our output is going to be a real value. Okay, so we can analyze the project now. After analyzing the project, we have to create a section. That is where we are going to carry out our calculation or our manipulation. Okay, and I'm going to call that section the scaling function. And we are going to program it with ladder. This is our scaling function. Now we double click on it to open the function. This is a function. We have to first of all check if the incoming value is within the specified limits. So to do that, I'm going to call the greater than block. And I want that if the value is greater than from max, I want to set that error. I want to set that error to the high state. And also, I'll bring the less than block. I want that if that value is, that is from min, if the value is less than this, that is out of range at the lower limit, then I still want to set that bit to logic 1 state. Okay, now we are done with our error processing. Now to the input value. So I have to first of all take that input value and convert it to a real value. Okay, but before we do that, we are going to bring in a function called the scaling function. So I will select this and then I will call the scaling function. So I will call the scaling function and I'm going to paste it here. Okay, I can just bring it down a little bit. Okay, so this is our scaling function, and whatever parameter that is coming from our sensor, which is actually this input value, we want to pass it to this scaling function. And what we are going to do is, since this scaling function, if you look at its parameter, its input is real. Okay, they have the parameter, which is a structure type, and the output is also real. We have to now convert our input value to a real value, and to do that, we have to bring in the integer to real block. So I will just type int to real. and I'll bring in that block. Okay, so enable the block, and I'm going to pass a value here, the value which we just created, okay, from our table. You can see it from here. This is the value that we just created, is it? And the output should go to, so I'll take this link, I'll take link. The output should become now the input. Output should become the input of our scale block. Okay, and I'm going to link these two as well. And what goes out of our scale block is the output. And now we have to define a parameter called a para, which is a structure. So this is what is going to take these values. It's going to take these 4 values which we created here. Okay, from max, from min to max and to min. So it's going to take these 4 values. So we have to create a para structure. So I'll just create now a parameter. So I'll call this variable parameter, and it should take the para structure to accept. Okay. Now we have to pass all these 4 values to this para structure. All right. We have to pass those 4 values so that those calculations can be performed at this scaling block, and then our output will be realized through this output variable. So to do so, because all of these variables, if you look, these variables, these 2 variables, or these 3, okay, we are not using the input at that level, that is a value, we're just using from max and from min. They are all int. And our para variable, if we go to our private variable, we will see the para which we just created. So if you look, these are the values. It takes all of them are real. Okay. So these 2 maximum values or extreme values, we have to convert them, which are integer, we have to convert them to real, which will pass to int max and int min and int max. Okay. So I'm just going to copy this block, and then I'll bring here, I'll paste, and then I'll paste again here. All right. Now what am I passing here? I'm passing from max. So I'm passing from max, or enable the block, and from max goes to, now I will search for my private variables parameter, and from max goes to, stretch this a little bit, so it's going to go to our in max. It's going to come here in max. Okay. And from min should go to private variables. So from min should go to, okay, in min. All right. Then I'm just going to link this up. Okay, so we have now successfully converted them to real, and we have passed them now to this, okay, to this structure. All right. Next, we have to now move. Okay, we have to now move these other variables. That is, these variables to max and to min. They are all real types, so we don't need to use a converter again. We just have to move them directly now to parameter now out max and parameter out min. Okay, so I'm going to bring in the move block. I'll place my move block here, and I'm going to enable the block, and from here it becomes to max. So max goes to out max, and I'll bring in another move block again. Then I'll just go ahead and link them up. This is now to min. So to min goes to the parameter out min. Okay, so you can see out min. Okay, good. So we have now assigned our 4 parameters, okay, for max, for min, and to max and to min, to the parameter structure. So now our function block is completed. We're just going to analyze the project, and I will build this one to check for errors. Okay, so let's see, we have an error. What does it say? Okay, so we have an error. It says this tool is not ready. All right, so I will analyze the project. I will build the project. So it is still not ready. Let's see what is wrong. Okay. We have to build this structure. All right, we have to build this DFD. So we have to analyze it rather. So we have to analyze it first. So analyze it to make sure that it is ready. Okay, now it is ready. All right. Okay, so always make sure that you analyze it, and you can now build a project. Tool is still not ready. What is the problem? Let me see. Okay, it is telling us that our module is not yet ready. So we made some change. We have to validate that change, right? So always make sure we validate it. We made some changes here we did not validate. So now we can build a project. Okay, everything looks fine now. All right, so what we are now going to do is since we have already created our project, we are now going to drag this. Okay, we are now going to drag this inside. Drag this, our DFB, inside this block. All right. So I'll go to my library. So this is our function block. We drag it into our environment. Yes. Good. And I'll enable it. Oops. I'll cancel this off. All right. So you can see these are the parameters which we define from max, from min to max, and to min, error, and out. All right. So we will now create now our program variables. And in our program variables, we will have now our input, which is an integer. So we'll have input. So I'll just say input var. It's an integer. Then we are going to have max in. So I'll just say max in. Also an integer. Max out. But for our max out, it is a real, not an integer. So it's a real variable. Then I'm going to have now min in, and our min in is an integer. Type is integer, and then we are going to have our min out, and our min out is a real value. Then we can have our error. Let's say we have our error. Okay, our error is bool. Let's just say it is boolean. Okay, some internal variable. Then we have our output, which we are just going to call result. And our result is real as well. Alright, so we have those variables. Alright, now what we are now going to do is we'll now go to our configuration. But before then, let's build a project to make sure that we have no errors. Yes. Good, we have no errors. Now we have to go to configuration. Okay, under configuration, we'll click on this module. And on this module, we can get some basic information about it. So this module, its output resolution is 12 bits. Okay, and the input resolution is 14 bits when we are working with voltage from plus or minus 10 volts. And it is 12 bits when we are working from 0 to 20 milliamps and 4 to 20 milliamps, as we can clearly see from here. Okay, the input ranges. So these are the different signals that we can measure. So we can spend some time to explore it. All right. So we're working with channel 1, okay, which we configured. And then I'll click here and I'll go to IO objects. So I will generate all the channels. All right. For that, I will generate all the channels, or we can generate. Let's say we generate all the channels. Okay, I prefer to work with channels. So generate all the channels, and in this channel we have to now assign some value. All right, because we are working with channel 0, we have to assign some value, and that value that we are going to assign will be our input value. All right, it's going to be our input value. Now we will go back to our table, and from our input value, which is this value, we are now going to alias that. Okay, so we'll alias it with that channel. Okay, so I'll bring up that channel. We didn't give the channel a name, so I have to give it a name. So I'll come here and I'll just call this channel. So I'll take the generic tag and I'll just call it channel. Let's just say CH0. Okay, which stands for channel 0. Then I'll take create, yes. Okay, so we have given it the channel 0. Now I'll go back to my table. Okay, and at the level of my input, I will alias that now with that channel. This is channel 0. I'm going to take the value and not the error. You can also see it's also a type, so it's another input value you can see from here, and this is the address to that value. Now I've assigned my input to that channel 0 input value. I'll go ahead and build the project. So now I'll go to my main function, and I'll now tag all those values which I created. So I'll start by for max. I'll start by for max, which is max in, for min, which is min in, to max, so it's to max, which is max out, and to min, which is min out. Then we have our output, which is result. Then we are just going to put now a coil here, and we are going to give that coil the error address. Alright, so we are now done. Okay, no, we are forgetting the value. So we have to pick the value, which is the input value. Now we can view the project again. Okay, so we have built the project. What we are now going to do is we will connect to PLC. Okay, so we want to connect to PLC. We are going to download our project to PLC. Having issues. Do this again. Okay, so we can now transfer our project to PLC. Oops. So we are going to transfer our project to PLC. Yes. Going to run after transfer. Yes. So what we are now going to do is we will go to our project. So everything is 0, 0, 0, 0. We have not set up anything so far. So what we are going to do is I'm going to create an animation table. I'll allow it default, and I'll bring all those values to this table. Control A, okay. Then I'll go to the modification mode. Now this is the value that comes from our inputs. Okay, so this is the value that comes from our inputs, and when we modify it, we should see it being modified. Okay, you see it modify this output result. So first we have to specify our input, our maximum input range. Okay, the maximum input range was 10,000, and the maximum output range. The maximum output range was 100,000, which is 100 kilopascal, and our minimum input range was 0, and our minimum output range was 0. Now for every input, okay, good. So what did you notice? You notice that I cannot modify this input value. It is because it's a physical value, and since a physical value, we cannot modify it. Okay, only the sensors in the field can modify, can give a value to this, because we have tagged it to a physical address. That's why we are not able to modify it. Now for the purpose of simulation, we are now going to set that to a memory address. Okay, we will set it to a memory address. So I'll go back now to my table, and instead of writing address iw0.1.0.0, I'm going to delete it from here. So I will delete it, and instead I'm going to give an address, a memory address. Okay, memory address, say percentage MW10. So I'll give you that address MW10 so that we can modify it and see how it affects the range. So we are going to simulate it instead. I will build a project again, and I'm going to go back to our animation table. So from our animation table, notice now that we have a tendency to modify the value. Alright, so if I set it to, say, if the input value is 25, so this is the equivalent pressure value. Okay, it's scaled pressure value. Alright, so we can better appreciate it if we take a look from here. Right, so I will just click here and then I'll click modify. Alright, so this is the maximum range 0 to 10,000, 0 to 100,000. Our value is 25. Now, if I want this value to be at 50,000, what do I need? I need I have to send the half of this value. So if I click here and then I send, say, 5,000. Okay, so if I send 5,000, then, oops, I've changed the wrong value. This is 10,000. And if I now click here and I send 5,000, notice that here we have 50,000. Okay, if we change this to 100, here we have 1,000. Okay, so you see that our values are scaled correctly. And if we change this to 1, for example, assume that we are having a value of 1. Okay, then the equivalent is 10. And now let's say that we go beyond this range. All right, let's say we go beyond this range to say 11,000. Let's say we go to 11,000. Now our error bit is set to show that we are out of range. All right, and when we come back to range, it goes off. If we go out of range at the lower limit, let's say we move to minus 45, then it is still activated, okay, to raise an alarm. And if we go back to within range, then it is off, okay. And also here we can change these values if we want to modify the range of operation, and it's going to automatically adjust itself, okay. I hope that this was informative enough. All right, so let's go back to the presentation. Okay, so congratulations, you have now understood what analog IOs are, the application of analog IOs, analog IO configuration, and analog IO programming. Okay, so please, if you did not understand anything in this video, put it in the comment section down below. And please, for your suggestion, we have really come a long way. And for your suggestion, if you would like me to produce other content or what you want me to produce next, put it in the comment section down below. And thank you for watching. And please also don't forget to subscribe, don't forget to like, don't forget to share this video with your friends, with your community. For those who love programming, those who are programming hobbyists, and for those who enjoy doing industrial automation like myself. And don't forget to hit the notification bell after subscribing so that you won't get to miss any of our upcoming videos. Thanks again once more, and bye bye.